Imagine a doctor delivers a life-saving diagnosis. You're relieved, but then you ask, how do you know? And the doctor points to a machine and says, I don't. The AI just says so. We have entered the era of the black box. We are building systems that can outthink us, outcalculate us, and outperform us. But there is a terrifying catch. We no longer understand how they think. In science, this is known as the black box problem. It's the gap between what an AI does, the output, and why it did it, the logic. We've traded understanding for power, and that trade might be the most dangerous bargain in human history. For decades, computers were transparent. If a program crashed, we followed the logic. If A, then B. It was a map we drew ourselves. But modern AI, it's not coded, it's grown. We feed it billions of data points, and it builds its own internal labyrinth of trillions of connections. It's a digital intelligence that evolved in the dark. This isn't just a technical glitch for Silicon Valley. This is about justice, medicine, and war. When an algorithm decides who stays in prison, who gets a heart transplant, or who is a target, trust me is no longer a good enough answer. Today, we're going inside. We're going to look into the heart of the machine to see if we can solve the greatest mystery of the 21st century. Can we ever truly trust what we cannot explain? To understand the mystery, we first have to understand what AI isn't. For 60 years, software was like a recipe. A human chef, the programmer, wrote down every single step. If the program did something weird, you could look at the recipe, find the line of code, and fix it. It was transparent. It was logical. It was human. But then we changed the game. Instead of giving the computer rules, we started giving it examples, millions of them. We told the machine, here are 10 million photos of cats. Figure out what a cat looks like. And the machine did. But it didn't look for ears or whiskers the way we do. It started seeing patterns in pixels, textures, and mathematical gradients that don't even have human names. This is where the black box is built. A modern large language model doesn't have 10 or 20 variables. It has hundreds of billions of parameters. Imagine a cockpit with a billion knobs and dials. You turn one a fraction of a millimeter, and it ripples through a trillion connections. No human brain can visualize a billion-dimensional space. We can see the input, and we can see the result, but the math in the middle? That is a digital wilderness where we are effectively blind. And here's the most unsettling part: emergence. As these models grow, they start doing things they weren't specifically trained to do. A model trained to predict the next word suddenly learns how to play chess, or how to write Python code, or how to manipulate human emotions. We didn't program those skills. They emerged from the depths of the black box. We built the engine, but we don't know all the places it can go. But what happens when this untraceable logic makes a mistake? What happens when the black box decides against you? A black box doesn't just process data, it inherits our flaws. We think machines are objective, but they are trained on a world that is anything but. If you train an AI on historical hiring data, it doesn't learn who the best candidate is. It learns who you hired in the past. If the past was biased, the future will be too. And because it's a black box, we can't see the prejudice hidden in the math. In the United States, an algorithm called Compass was used to predict how likely a defendant was to commit another crime. It influenced bail, sentencing, and lives. But when researchers looked inside, they found a disturbing pattern. The system was twice as likely to falsely flag black defendants as high risk. Why? The developers couldn't explain the exact logic. The system was proprietary, a black box deciding a human's freedom. In medicine, the stakes are even higher. A few years ago, a neural network was trained to identify skin cancer. It was incredibly accurate, almost too accurate. When researchers finally used interpretability tools to see what the AI was looking at, they were shocked. The AI wasn't looking at the moles, it was looking for a ruler. Because doctors often placed a ruler next to cancerous lesions in photos, the AI simply learned ruler equals cancer. It was right for all the wrong reasons. Now scale that up to the global economy. High-frequency trading algorithms move trillions of dollars in milliseconds. These black box bots interact with each other in ways no human can track. They can trigger a flash crash, wiping out billions in seconds without anyone knowing what triggered the chain reaction. We've built a financial ghost in the machine that can bankrupt a nation before we can even press pause. Accuracy without accountability is a trap. If we don't know how the machine arrived at its answer, can we really say we are the ones in charge? We aren't just giving up and letting the machines take over. A new field of science is emerging: mechanistic interpretability. Think of it as digital neuroscience. Just as doctors study the human brain to understand why we feel fear or joy, AI researchers are now probing the brains of these models. They are trying to find the exact circuit that makes an AI lie, or the specific cluster of neurons that understands the concept of justice. Recently, researchers at Anthropic made a breakthrough. They managed to map millions of concepts inside a top-tier AI. They found that when an AI thinks about the Golden Gate Bridge, a specific pattern of millions of virtual neurons lights up. By artificially turning up that signal, they could make the AI obsessed with the bridge. For the first time, we aren't just guessing. We are starting to read the machine's mind. Another tool in our arsenal is the saliency map. It's like a heat map of the AI's attention. It shows us exactly which pixels a self-driving car is looking at before it decides to brake. If it's looking at a child on the sidewalk, good. If it's looking at a random shadow on a billboard, we have a problem. These maps are the glass box we are trying to build. But there is a massive trade-off. Right now, the more transparent we make a model, the less powerful it becomes. Complexity is the source of AI's intelligence. If we force it to be 100% understandable to a human, we might strip away the very magic that makes it useful. We are walking a tightrope between an all-knowing God we can't understand and a simple tool that can't solve our greatest problems. We are living through a new era of digital alchemy. Centuries ago, alchemists mixed substances to create gold. They didn't understand the chemistry of atoms or electrons, but they knew that sometimes it worked. That is where we are with AI today. We have found the formula for digital gold, but we are still discovering the laws of the universe it inhabits. We are masters of the what, but apprentices of the why. But the world is waking up. From the European Union's AI Act to global safety summits, the demand is clear. Explainability is no longer optional. We are moving towards a future where an AI's right to exist will depend on its ability to explain. If a machine cannot show its work, we might have to turn it off, because power without accountability is just another word for tyranny. This is the greatest challenge of our generation. We are building a mirror that is starting to think for itself. If we can't understand the black box, we risk becoming the subjects of our own creation. We don't just need faster algorithms or bigger models. We need a bridge between human intuition and machine logic. We need to turn the black box into a glass box, where intelligence is not just powerful, but shared. So, here is the question for you. Would you trust a doctor who is 100% right, but can never tell you why? Or would you prefer a human who is sometimes wrong, but can look you in the eye and explain their mistakes? The answer to that question will define the future of our species. Thanks for watching.